Hello and welcome to AzureMonk.com. In this video, we will simplify and demystify how upgrades work in an Azure Kubernetes service cluster in plain English. We'll cover the two kinds of upgrades, that is the Kubernetes version upgrade, the NodeImage version upgrade, and also how to automate the upgrade process using auto upgrade channels. Let's talk about the first kind of upgrade, the Kubernetes version upgrade. Let's assume our Kubernetes cluster is at version 1.19.12. Let's break this down. In this, the number 1 represents the major version, and 19 represents the minor version, and 12 represents the patch version. Every quarter, Kubernetes releases a new minor version, and at any given point, Azure supports n-2 minor versions. So for example, let's say in this case, our cluster is in 1.19 and the latest version is 1.21, then 1.19 is the last supported version. So if we need to upgrade our Kubernetes version of our cluster, can we directly upgrade to the latest minor version, that is 21? Well, no. Upgrades are performed on a per minor version basis. So first from 1.19 to 1.20 and then to 1.21. The only exception to this is if your cluster is completely out of the supported version. Now that we understand that, let's talk about how Azure Kubernetes Services is structured. In AKS, we have a control plane, which is managed by Microsoft, and then we have worker nodes which are deployed as node pools. But having said that, you can have the control plane and the worker nodes in different Kubernetes versions as long as the following conditions are met. The major version for the control plane and the worker nodes must be the same. The node pool version cannot be greater than that of the control plane version. The last criteria is the minor version for the worker nodes must be within 2 minor versions of the control plane. Great. In order to list the Kubernetes version and the available Kubernetes version upgrades of the control plane, we run the following command. All the commands run in this video and the steps are part of the description below in the video. We run AKS get upgrades, resource group, and we specify the output. In our case, we see that our cluster control plane is running on version 1.19.11 and the following updates are available. 1.19.13, 1.20.9 and 1.20.13. And if you need to list the Kubernetes versions of all the nodes in your node pools, you can run the following command. Once you run this command, we can get a list of the outputs. In this case, we see that our agent pool is running 1.19.11. Our pool 1 is also running 1.19.11, as well as our Win1, which is our Windows node pool, is also running 1.19.11. There are 3 ways to upgrade the Kubernetes version. You can upgrade all the nodes at once, you can upgrade only this control plane, or you can upgrade only specific node pool. But wait, before we dive into the actual commands to upgrade the nodes, let's take a look at the process. Let's say we want to upgrade the Kubernetes version from version 1.19.11 to 1.20 on one specific node pool with 3 nodes which has several deployments and pods running inside it. How does that work with least disruption? Here's what would happen when we initiate the upgrade command. A new buffer node gets added to the cluster that runs the specified Kubernetes version, that is 1.20.9 in our case. AKS then cordons one of the old nodes. What cordon does is it makes this old node not schedulable such that no new pods are added to it. Great. This ensures no new pods are scheduled on the node. But what about existing pods? AKS then drains one of the old nodes to minimize the disruption to running application. This drain will move all the pods from the old node to the buffer node that was added. Once the old node is fully drained, it will be re-imaged to receive the new Kubernetes version, that is 1.20.9, and it will be pretty much empty. This node now becomes the new buffer node for the next old node that we want to upgrade in the node pool. This process repeats until all the nodes in the clusters have been upgraded. At the end of the process, the last buffer node will be deleted, maintaining the existing agent node count and the zone balance. If we want our upgrade to run faster, we can increase the max surge number or the percentage, which means more nodes are added and hence more parallel upgrade operations are possible at the same time. However, that also means more nodes are drained in parallel. The recommended percentage is to go with 33% of the total number of nodes in your cluster for production workloads. That is, if you have 9 nodes, keep max surge to 33%, which means 3 buffer nodes will be added at a time. Great. Now that we have an understanding of how the upgrade works, let's take a look at the actual commands to upgrade. In order to upgrade all the nodes at once, we run the following command. This will upgrade all of the control planes and the worker nodes at once to the desired Kubernetes version. If we want to only upgrade the Kubernetes version for our control plane, we run the same command, but this time with the control plane only switch. If we need to upgrade the Kubernetes version on only specific node pools, we can run the following commands by specifying the node pool name and the desired Kubernetes version. We talked about Kubernetes version upgrades. Let's now talk about NodeImage upgrades. Microsoft provides patches and new nodes weekly, but it doesn't automatically patch them. Outside of the Kubernetes version updates, there are also updates related to OS security patch, kernel updates, Kubernetes security updates, newer versions of binaries like kubelets, as well as other components. In order to upgrade this, we can use the AKS nodepool upgrade commands. Let's take a look at the steps that are needed to get this done. Running the following command lists all the current NodeImage versions of the node pool. Once you run that, in this case, we see our agent pool, our pool 1 and our Windows 1 is running on a specific NodeImage version. We also see that for Win1, we see AKS Windows 2019 as the node version that it's running. We can then run the following command to list the available NodeImage version available for us. We can run this on the Linux node pool, the agent pool, as well as the Windows 1 node pool. In our case, let me go ahead and run it for the pool 1, which is our Linux workload. We see the latest NodeImage version. There are 2 ways to upgrade. Upgrade the NodeImage version for a specific node pool, or upgrade the NodeImage version for all the node pools at once. In order to upgrade the NodeImage version for a specific node pool, we run the following command. AKS nodepool upgrade with the switch of the node pool name as well as a switch saying NodeImage only. Once complete, we can run the following command and look for the NodeImage version to ensure that the updated node pool details are what we desire. Great, we see that the update has completed successfully on the specific node pool. In order to upgrade the NodeImage version for all the node pools at once, we run the following command. AKS node upgrade, but this time with the NodeImage only switch and no node pool name. Remember, if you don't specify the NodeImage switch, the whole cluster, including the Kubernetes version of the control plane, is also upgraded. Great. Once complete, we can run the following command and look for the NodeImage version again to check that the updated node pool details are intact. Great, we see that the update has completed successfully on all of the nodes. We discussed Kubernetes version upgrade and NodeImage version upgrade. Let's say you didn't want to do any of these upgrade options manually like we just did and preferred an automated way to upgrade your cluster. as soon as a new Kubernetes minor version or a new OS patch is released. Is there a way to do it? Glad you asked. You can choose the auto upgrade option and enable it on an existing or a new cluster to ensure your cluster is always up to date. In order to enable this on an existing cluster, we run the following command. Here, the value after the auto upgrade channel determines what kind of upgrade would occur in the cluster. I'm pretty much going to go with the description of these values from the docs because it's very self-explanatory. The default value is set to none, which means auto upgrades are disabled. We then have patch, which automatically upgrades the cluster to the latest supported patch version, but it does not modify the minor version. For example, if a cluster is running 1.19.11 and the latest versions available were 1.19.19, 1.20.4 and 1.21.6, your cluster is upgraded to 1.19.9 since that is the latest patch. The next option is stable, which automatically upgrades the cluster to the latest supported patch release on a minor version n-1, where n is the latest supported version. For example, if the cluster is running 1.17.7 and versions 1.17.9 and 1.18.4, 18.6 and 1.19.1 are available, your cluster is upgraded to 1.18.6 because that is the latest supported patch release on a minor version n-1. Rapid automatically upgrades the cluster to the latest supported patch release on the latest supported minor version. In cases where the cluster is at a version of Kubernetes that is at n-2 minor version, where n is the latest supported minor version, the cluster first upgrades to the latest supported patch version of n-1 minor version. For example, if a cluster is running 1.17.7 and versions 17.9 and 18.4 and 18.6 and 19.1 are available, your cluster first upgrades to 18.6 and then to 1.19.1. The last option is the NodeImage, which automatically upgrades the NodeImage to the latest version available. This will automatically upgrade the NodeImage version when a new image becomes available. Great. I hope that provided clarity on the upgrade process around Azure Kubernetes services. There is also the GitHub Actions method, which we won't cover in this video. Thank you for watching. I'll see you again in the next video.